So in this video, we are going to discuss a lot of the basics of chemistry, starting off with the structure of an atom and ending with discussing the most useful tool that we have in chemistry, the periodic table. So let's start off with some atomic structure, and probably a lot of this is review for most of us, but it's important that we all have this basis of understanding to start. So atoms are made up of subatomic particles. And these subatomic particles, we call them that because the prefix sub means under or smaller than the thing that they make up. So our subatomic particles are our protons, neutrons, and electrons. And you probably know all these subatomic particles and have heard their names before, but we're just going to review their different symbols, their mass, where they are located in the atom, and of course their charge. So at the bottom of this slide, you can see a couple of different models of the atom. The one on the left here is often referred to as the nuclear model of the atom. And then the one on the right you're probably most familiar with these concentric rings called the Bohr model of the atom. And we'll learn more about these specific types of models later in this semester. But for now, we just want to be able to point out the parts. So in the middle of our atom on either side, whether we're talking about the Bohr model or the nuclear model, we have what's called the nucleus. And two of our subatomic particles are in the nucleus, the protons and the neutrons. And then around the nucleus, either on these concentric rings in the Bohr model or on these kind of randomly placed orbitals in the nuclear model, we have our electrons. So protons and neutrons are in the nucleus, and then we have our electrons circling the nucleus. So when we want to denote that something is a proton, we use a symbol, a lowercase p, with a superscript of a plus sign. The neutron we denote with a lowercase n with a 0 as the superscript, and an electron a lowercase e with a minus sign as the superscript. So in our atom, we found out a long time ago, some scientists, Ernest Rutherford, determined that most of the mass of the atom is concentrated in the middle, in the nucleus. And so two of our subatomic particles have a significant amount of mass, and those are our protons and our neutrons. So the mass of a proton is considered to be about 1 atomic mass unit, and the mass of a neutron is also about 1 atomic mass unit, and we abbreviate that AMU. AMU. And then the mass of an electron is very small, much smaller than the mass of the proton or the mass of the neutron. And so we say that the mass of an electron, when we are figuring out how much mass an atom has, is negligible, meaning that it doesn't really matter because it's so super duper small in comparison to the protons and the neutrons. So under mass here I'm going to write negligible, meaning that we just don't really need to count it because it is so tiny. Then the location of our subatomic particles, well, we already said that the protons and the neutrons are in the nucleus. And then our electrons are around the outside of the atom. So I'm just going to put around. They're hard to predict where they are because they are moving so super duper fast. And then last but not least, let's review the charges of these subatomic particles. So first of all, protons. I always think P and P, proton is positive. So protons have a positive 1 charge, proton positive. Our neutrons are neutral. They're also found in the nucleus, but they have no charge. And when something is neutral and has no charge, we denote that with the number 0, meaning nothing. And then our electrons actually have a -1 charge. So let's talk a little bit about these models. So you might look at this Bohr model over here and you say, okay, I can know which one of these subatomic particles in the middle is the proton because I know that protons have a positive charge. So this must be the proton here. And then the other particle must be the neutron because it doesn't have any charge noted. We look over here at the model of the lithium ion and you can't really tell which ones are the protons and which ones are the neutrons. But you still can know by looking at the periodic table because the type of atom that we have is defined not by the number of neutrons and not by the number of electrons, but by the number of protons that something has. And you might remember looking at a periodic table from back in 8th grade that the whole number that's in the periodic table block is called the atomic number. Atomic number. And that atomic number tells us the number of protons. It's the same as the number of protons. So we know that lithium has 3 protons. And down in this picture here, we see that there are 4 of these gray circles and only 3 of the blue circles. So we can be pretty sure from there that the blue must be the protons because that determines that it is a lithium atom. So just a little trick there. We'll talk more about that in a little bit. Let's move to the next slide. So let's practice determining the type of element and determining the charge. So over here, then letter A, we have 3 electrons around the edges. We have 3 positively charged protons and 1 neutron. So only one of those subatomic particles tells us what element it is. And we said we have 3 protons. That indicates to us that it must be atomic number 3, which we already said was lithium. So based on those number of protons, we can say that this element is a lithium atom. And then to determine charge, we need to look at the balance of protons and electrons. So we have 3 protons, so 3 plus 1 charges. And we also have 3 electrons, so 3 minus 1 charges. So if we have 3 positive ones and 3 negative ones, then our overall charge is neutral, meaning that we have a charge of 0 on this atom. But then looking at letter B, we have 9 protons. And we know that protons will tell us what type of element we have. If you pull out a periodic table now and go over to atomic number 9, you'll notice that atomic number 9 is fluorine with a capital F as its chemical symbol. So that gives us the type of element, and now we just need to figure out the charge. And so here we know we have 9 protons, so 9 positive 1 charges. And then we have some number of electrons. Let's count them here. We have 2, 4, 6, 8, 10 electrons. We have 10 minus 1 charges. So we have plus 9 and then minus 10. Our overall charge of our atom is going to be -1 because we have more negative charges than we have positive charges, resulting in our fluorine atom having a -1 charge. And when we have an atom or molecule that has a net electrical charge, we have a different name for that type of atom. We call that an ion. Ion. And ions result due to an atom gaining or losing electrons. Now, let's talk for a second about that. So there's some important notes on this. Most importantly, that an atom cannot gain or lose protons to become an ion, because if we gain or lose protons, then we have a completely new element. It is no longer the same element. If we added another proton to our fluorine atom, then we would have neon. It would no longer be fluorine at all. It would be the element neon, which is atomic number 10. So if the number of protons is changing, we are no longer just in chemistry. We are in a specific branch of chemistry called nuclear chemistry, meaning that we are changing the nucleus of the atom. And in general chemistry, we are not really concerned with changes to the nucleus because we need huge amounts of energy to make these changes happen. We are really only concerned about the movement and changes of electrons. So that's what we focus on in chemistry class, is the things that electrons can do and the things that happen that we can observe when electrons are moving around and changing and switching from one atom to another, or speeding up or slowing down, or all sorts of other things. All of chemistry has to do with stability. Everybody wants to be stable. And when I say stable, I mean low energy. An atom wants to expend only as much energy as it absolutely has to. It doesn't want to use more energy than it has to because it's lazy, much like most people. I'm lazy. If I don't have to get up and go to the fridge, I don't want to have to do that. So I want to be as lazy as I possibly can. And ions form because atoms want to have a full set of valence electrons, because that full set of valence electrons is going to help them be more stable. Now, valence electrons, they are the electrons in the outermost shell of our atom. Outermost shell of our atom. So in this atom here, we have 9 protons. We know it's a fluorine atom. We're not concerned with these electrons in the middle. We only want to look at the valence electrons. So these are the ones on the outermost shell. So these ones, and this one guy right here. So if we count up the valence electrons, we have 2, 4, 6, 7 valence electrons. But there's a rule called the octet rule that says that atoms, to be the most stable that they possibly can be, need to have a full octet. Octet meaning that they need to have 8 electrons. And this state of being is the best way for them to maximize their stability and expend as little energy as they possibly can. So this fluorine atom right here, it has 7 valence electrons, but it wants to have 8 valence electrons. So it's going to gain 1 more electron to get to 8 valence electrons in its outer shell. And when it gains that 1 electron, that's when it has a charge and becomes an ion, because it now has 1 more electron than it has proton. It has 9 protons, and now it has 10 electrons in its most stable state, giving it that -1 charge. There's a couple of exceptions to the octet rule. Elements 1 through 5 actually only want to have 2 electrons in their outer shell, and we call that a duet. So if we want to determine the number of valence electrons more easily, there's actually a very, very quick way to do this using the most wonderful and best cheat sheet you get in chemistry class, which is the periodic table. So in the periodic table, let's talk a little bit about the structure of it. We have columns, those going up and down, and then we have rows of the periodic table. And we number these columns of rows, and then we also have different words for them. We call a column of the periodic table a group, and we call a row a period. So if we want to determine the number of valence electrons that a given atom has, we simply need to look at the group that it is in. So all of the elements in group 1 of the periodic table have 1 valence electron. All the elements in group 2 of the periodic table have 2 valence electrons. We're not going to worry about these elements in the middle here. We'll worry about them later, but they have some kind of weird behaviors that we're not going to concern ourselves with now. So then we're going to skip over to group 13. Now, these guys don't have 13 valence electrons. We're going to take that 13 and knock off that 1. So they have 3 valence electrons. And then in group 14, we're going to knock off that 1. These have 4 valence electrons. And then 5, 6, 7, and 8 valence electrons. So it's super duper easy to determine the number of valence electrons as long as you can count across the periodic table and figure out what group something is in. For groups 1 and 2, the group number is equal to the number of valence electrons, and for groups 13 through 18, all you have to do is knock off that 1, and then you have the number of valence electrons. But what about determining charge? Well, the charge that an atom's ion has is directly related to the number of valence electrons that they start with. So atoms that have 3 or less valence electrons are going to tend to lose their valence electrons to get to a full octet. They basically just, their outer shell, they lose all the electrons in the outer shell, and then the next shell down then becomes the valence shell. So they lose their electrons, and when they lose electrons, they now have more protons than they have electrons, so they have a positive charge. And we call these types of ions cations. Then, if you have an element that has 5 or more valence electrons, so group 15 all the way over to the right, they're going to tend to gain electrons to get to a full outer shell of 8, because it's easier to gain 3 than it is to lose 5 electrons. And when they gain electrons, they're going to have a negative charge, and we call a negatively charged ion an anion. So 3 or less, we're going to lose electrons, become a positive ion. 5 or more, we're going to gain electrons, become a negative ion. So real quick, what would the charge of a sulfur ion be? So looking at our periodic table, we can see where sulfur is. Sulfur is right over here, atomic number 16. And so if we look at what group it's in, we see it is in group 16 as well. If we knock off that 1, that gives us 6 valence electrons. So we definitely have 5 or more, so we're going to gain electrons to get to 8. We need 2 more electrons to get to 8. So if we gain 2 electrons, that's going to give us a charge of -2. So if we want to write that in something called ion notation, we're going to start by writing the chemical symbol, capital S, and then we're going to put this -2 as the superscript, show that we have an S2- ion. So let's take a little practice here with our periodic table. So our atom is magnesium. So let's find magnesium. It's atomic number 12 right over here. Number of valence electrons. So to determine the number of valence electrons, all we have to do is look at what group it's in. We see it's in group 2, so we have 2 valence electrons. To determine its charge, we need to figure out first if it's going to gain electrons to get to 8 or lose electrons to get to 8. It would have to gain 6 more electrons to get to 8 valence electrons, and it would only have to lose 2 electrons. So the easier thing to do would just be to lose those 2 electrons. And if we lose 2 negative charges, we're now going to have a +2 ion charge. And if we write that in the ion form, it would be Mg with +2 as our superscript. You can also write it the other way as Mg and then 2+. Either way is correct. Up next, we have phosphorus. Looking over, it's atomic number 15, group 15 of the periodic table, so we're going to knock off that 1, and we have 5 valence electrons. So we would need to either lose 5 or gain 3 valence electrons to reach our octet. It would be much easier to gain 3 electrons, so we're going to end up with a -3 charge because we have 3 extra negative charges, and we can write that as P3- or P-3, whichever you like. Next we have potassium, capital K, which is found atomic number 19 in group 1 of the periodic table. So we know that we're going to have 1 valence electron, and clearly it's much easier just to lose 1 valence electron than it is to gain 7. So if we lose one electron, that's going to leave us with a +1 charge. Then we have neon. Neon is found all the way in group 18, atomic number 10. So if it's in group 18 and we knock off that 1, that means we have 8 valence electrons. If we already have 8 valence electrons, we don't need to gain or lose any electrons to get a full outer shell. We already have 8. So our ion charge is going to be 0, meaning that neon is not going to form an ion. All these elements in group 18 are a super special group of elements called the noble gases. And they're noble because they already are perfect in that they have 8 electrons. They don't need to gain or lose any electrons. The last thing we're going to talk about in this video is a way to show how many valence electrons an atom has. And this is just a visual way of showing the number of valence electrons called a Lewis dot structure. And it's just a diagram that represents the valence electrons of a particular atom. So when you're drawing a Lewis dot structure, all you do is you take the chemical symbol and then you place dots around the chemical symbol to show the number of valence electrons. So let's say we wanted to write a dot structure for oxygen. Oxygen's chemical symbol is capital O, and then it has 6 valence electrons since it is found in group 16. So I'm just going to start putting dots around oxygen. The one thing to note about doing this is that you shouldn't put 2 dots on one side until every side of the chemical symbol has 1 dot. So when I put my dots, I'm going to start by going up 1, 2, 3, 4, and then I'm going to start putting doubles. 5, 6, and then that's all I need. So 2 sides of my oxygen have 2 dots, and 2 sides only have 1 dot for a total of 6 valence electrons. Let's try doing the dot structure for chlorine. So chlorine in group 17. So chlorine is going to have 7 valence electrons. I'm going to put my chemical symbol Cl, and then I'm going to go 1, 2, 3, 4, 5, 6, 7 valence electrons. So after watching this video, here's a list of all the things that you should be able to do. So please check through this list and make sure that you understand how to do every single one of these target goals.